All right. Hey, welcome everybody. We're going to look at today, we're going to talk about some things, our last geometric transformation, and today that's going to be a dilation. Remember, we talked about so far, we've talked about translations, which are slides, rotations, which are turns of an object, and reflections, which is flipping an object across a line of reflection. Okay. Remember, those three were all rigid transformations because they did not change the size of the object. All they did was change either the location or the location and direction of the object. Remember, those objects were congruent to each other, which means they had the same shape, same size, and same angle measurements. Everything was equal, so they were literally identical objects. When we translated anything, it was just slid over. The shape was the same size. It just changed location. A rotation, remember, all it changed was the direction and the location. The size was still the same. And then with a reflection, all it changed was direction and location as well. All right, so we're going to look at dilations today. When we started on these in class today, and remember what a dilation does. So that's the main question. Everybody says, what does a dilation do to an image? Well, on the coordinate plane, what it does to an image is it's going to make it either get larger or it's going to get smaller. Okay, so it's either going to make it grow, which is going to get bigger, or it's going to make it get smaller. So now we're actually changing the size of an image. So that's what we talk about now, because now this will change the size but not the shape of the image. So now we're not talking about congruency anymore. Now we're talking about an image that is similar to the other one. So kind of like what I talked about today, if I draw a right triangle, and y'all, I know this is a terrible right triangle. This angle is still 90 degrees. Well, if I draw one, it looks kind of like it. Not as tall, but it still has the same angle measurement. So this one is similar because it has the same shape, same angle measurements, but not the same size. Remember, we talked about now, because it's similar, your sides are going to be proportional. Okay, so it's going to change the shape, change the size, but not the shape. Remember, we talked about the scale factor today. The scale factor, remember, we abbreviated with a scale factor of, we called it a K. Remember, to do the bigger or the smaller, your scale factor had to be bigger than 1. It got bigger. Your image grew. Or if your scale factor was less than 1, then your image got smaller. Okay? So that's all we're going to do with a dilation. We're either going to make it get bigger or we're going to get smaller. The only thing that's going to change is going to be the size of the image. And I kind of answered my own question here. So how can I tell? Well, if before I even graph it, I can look at the scale factor, and that scale factor is going to tell me if it's going to get bigger or smaller. Okay, well, and that's just the basic, the starting point for that. So how do I dilate on the coordinate plane? Well, remember, all you're going to do on the dilation is you're going to take the scale factor, so you're going to multiply, and I know I'm writing this, multiply each coordinate pair by the scale factor. In other words, what you got is, if you think about this, I know it's kind of difficult to think about. Remember, the coordinate pairs are x and y. Okay, so what you're actually going to do is you're going to multiply the scale factor times the x and the scale factor times the y. Okay, so kx, ky. Kind of give you an example. Let's just say this: I had a pair that was 2, 4. I'm going to kind of go give it in just a minute on the coordinate plane. And I had a scale factor of 3. Well, all I'm going to do is take this x coordinate. 2 times 3 is 6. And then 4 times 3 is 12. So my new pair, the prime image, would be 6, 12, because this image is 3 times bigger than that one. Okay, that's just a quick intro. I know it's kind of fast, so take your time and go back and look at this again. Look at your notes we did today in class. But this is what you've got to make sure you understand, that the scale factor greater than 1 is going to make it get bigger. If you'll notice, this number, my 6, is 3 times bigger than 2. 12 is 3 times bigger than 4, because I did a scale factor of 3, so it got bigger. So let's see what one actually looks like, actually performing the action. Okay, we want to dilate MNOP by a scale factor of 2. So here's my rectangle, my square MNOP. we're going to use the scale factor K2, and I've given you the points. M is at this point, N, O, and P. All I'm going to do is take these points, and I'm going to multiply them by 2. So M prime, if you look right here, negative 3 times 2 is negative 6. Negative 3 times 2 is negative 6. Okay, N prime, I take the coordinates, multiply times 2, negative 3 times the scale factor of 2 is a negative 6. Positive 3 times 2 is also, well, it's just a positive 6. Then I have O prime. All right, both of these are 3, so 3 times 2 is 6. 3 times 2 is 6. So both of those are 6. 6. And then you have P, which is 3 times 2, so P prime would give me 3 times 2 is 6. Negative 3 times 2 is negative 6. Okay, so before I graph this, before I do anything, I always like to look and make a prediction. Well, my prediction is I'm looking at my scale factor. This image should get bigger because the scale factor is greater than 1. So let's see. So if I graph M prime, so I go negative 6, which is right here. There is M prime. N prime is negative 6, positive 6. There is N prime. O prime is positive 6, positive 6. There's, oh, that's not Q, excuse me, O prime. And then P prime is 6, negative 6. There's P prime. And I'm going to do my best to connect this, but y'all be patient with my... Oh, and I may say I made a mistake here. Let's go back and fix this for right now. I went over the wrong line. Okay, let's go back and fix this. This should be negative 6, 1, 2, 3, 4, 5, 6. Okay, I do apologize. That's N prime. So now when we connect it, tell you what, let's do it this way. It's a lot easier just to use this. Let's connect it this way. So now when I connect it, I have the same shape but not the same size. So this image is similar. The angles are the same shape, different size. Okay, see how it works? All you're doing is multiplying. Let's try one more. All right, this one's going to do a scale factor triangle ABC by 1/2 scale factor. I've given you the points again. So what we're going to do is if you look at your scale factor of 1/2, it should get smaller because 1/2 is less than 1, right? Okay, so we got A prime. So what we're going to do is we're going to say negative 4 times 1/2. Okay, that's going to okay, so negative 4 times 1/2, and then we'll do negative 2 times 1/2. Okay. All right, this is where we get to use our calculator. All right. Remember, mine doesn't. This was not going to do like we had the one we have in class. So I'm kind of have to work on this a little bit. So I want to go negative 4 times, and now to put my fraction in, I have to do it this way: 1 divided by 2. Close it up, and there's my answer right there. So I got negative 2. Okay. Now let's go negative 2 times 1/2. So we have negative 2 times 1/2 gives me negative 1. So A prime is going to be at negative 2, negative 1. All right, let's go with B right quick. Let me erase this over here, and we'll just kind of keep using this point over here to do the math with, okay? All right, so we got B. We have negative 4 times 1/2. Now, some of you may say, well, I'm really dividing, and yes, you are. If you multiply them by 1/2, you're really dividing by 2. And some of you may say, I'm just going to take half, but I want you to get used to doing this with the multiplication because sometimes you may not be able to do it in your head, okay? So what I have, let's go back with a calculator. So we have negative 4 again, okay, times 1/2 is equal to negative 2. So we have negative 2 again. All right, and then we have negative 8 times 1/2. So we have negative 8 times 1/2. And I'm doing the same thing your calculator's doing. I'm just having to do it the long way. Negative 4. All right, so we have B prime is now negative 2, negative 4. All right, let's do C prime and see what we come up with there. All right, so we can erase this. All right, and we have negative 8. Well, I don't really need to do this again because I've already done negative 8, right? We got negative 8. We ended up getting negative 4. So I'm going to be using that. Sometimes if you look what you did, there's no sense in doing it twice because we've already done negative 8. So there are my new coordinates. So let's plot them. So here's A. A is at negative 2, negative 1. There's A prime. B is at negative 2, negative 4. There's B prime. And C is at negative 4, negative 4. There's C prime. Okay, so all I'm doing, guys, it's just multiplying. Okay, even though, again, like I said, some of you are going to say, well, you're really dividing. Well, part of it I am. Excuse me, I know this is supposed to be a straight line, but again, you have this. But I'm multiplying, but I am dividing, but I'm using the multiplication symbol on my calculator. All right. So what I should have now, this should be a straight line, and it would be a similar figure because we have a right triangle here and a right triangle here. Same shape, different size. All right. Let's see. I think we got one more. Oh, we're going to do a little bigger one. Oh, this is going to take a while for this one. Maybe not. We got a scale factor of 1/2, 1.5. Okay. Sometimes you may see it written as 3/2, but still that improper fraction is, I'm sorry, that's not 3/2. Excuse me. I'll take that back. Yeah, it is. I'm sorry. 3/2. So you have a scale factor of 1.5 or 3/2. Either way, the improper fractions are always bigger than 1. So this one should get bigger. It should grow. Okay? All right, so we're going to multiply each one of these coordinates by 1.5. So here's A. So let's go 0 times 1.5. Well, that's an easy one. That's 0. So then we have 4 times 1.5. So let's take our calculator. 4 times 1.5 should give me 6. So there is my coordinate for A prime is going to be at 0, 6. All right, B prime. B is at 1, so 1 and 1 is going to be 1.5 and 1.5. All I did was 1 times 1.5 and 1 times 1.5. All right, C prime, we have 3 times 1.5. So we have 3 times 1.5. Oh, excuse me, 3.5. So 3 times 1.5, not 1.2. Okay, so that's 4.5. And we've already done 1, so we have 1.5. Again, there's no need to do it twice. You've already done it, okay? What about D prime? Well, D is 1, negative 1. Well, we did it right here. All we just need to do is watch our sign. So 1 times 1.5 is 1.5. And then negative 1 times 1.5 is negative 1.5. All right, E, 2 times 1.5. Well, we haven't done 2 yet, so let's go right here. 2 times 1.5 times 1.5 should give me 3. So we're going with E. That's going to be 3. And we've done 4. So negative 4 will be the same coordinate. Well, if I look right here, 4 was 6. So negative 4 is going to be negative 6. Okay. So you can see sometimes it just pays attention to use some of the numbers you've already used. Okay. So F prime is 0. That's an easy one because 0 times anything is 0. And then negative 2, well, we haven't done a negative 2, but we have done a positive 2. So if you look at the x coordinate on E, 2 times 1.5 is 2, so 2 times negative 2 would be negative 3, right? See what I did? I just used that same number. I just changed the sign. All right, let's go right here with G. There's that negative 2 again, so we have negative 3. Now, 4. Well, we've already used a negative 4 right here. Look at the y coordinate in E. So if I go to y coordinate in E, that's going to give me negative 6. All right, so we're almost done. So that's G prime, that's H prime. Negative 1, negative 1. Well, this is the same coordinates as B. We're just going to change the sign. So negative 1.5 negative 1.5. Okay, once you do a few of these, they kind of work themselves out. Okay, here's I, negative 3, positive 1. Well, we haven't done a negative 3, but we have done a positive 3. But again, all I'm doing, guys, I'm just multiplying negative 3 times 1.5. If you want to see it, we can do it this way right here. We can do negative 3 times 1.5. And that gives me my negative 4.5, which is just the opposite of that, right? So negative 4.5. And then the second one in I is negative 1. Well, we've done negative 1. We just did it. So negative 1.5. And then the last one is going to be J. Okay? All right, J is negative 1, positive 1. Well, it's just the opposite of D. Look at D. D is 1, negative 1. Just swap the coordinates. I'm sorry, swap the signs. So from D, I'm going to go negative 1.5, 1.5. Okay, all I did was multiply the x coordinate times the scale factor, the y coordinate times the scale factor. And that's all I did for every one of these, except I just did it the shortcut way. All right, so let's graph one. Let's see if we can graph this. Okay, A is at 0, 6. Now it should get bigger. Well, I'm off to a good start because that one is definitely bigger. Okay, B is at 1.5, 1.5. So 1.5. Right, 1.5 is between 1 and 2, so that's right here. And then 1.5, which is going to put it about right there on B. Okay, all right, so we've done this one, we've done this one. Now 4.5, 1.5. Okay, this is where you got to kind of watch. Right here, it's in the middle again. This one should be in the middle too. Okay, so go right 4.5. 1, 2, 3, 4.5, and then we got to go up 1.5. Okay, so 4.5, 1. There's my half right there. There is C prime. All right, we've done C. Let's go do D. 1.5 down 1.5. Well, it's going in the same place as this one, but down here, right? 1.5 down 1.5. There is D prime. And if you'll notice, these numbers are all on the outside, so they are getting bigger. All right, E prime is 3, negative 6. That's way down here. F is at 0, negative 3, which is right here, F prime. Okay, so we've done this one and this one. Now we got G, negative 3, negative 6, which is right here, which is G prime. All right, negative 1.5, negative 1.5, 1.5, 1.5, right in the middle of that box. I went left 1 and then half a box. I went down 1 and then half a box. That gives me H prime. Okay, and then I prime is left 4.5, down 1.5. Oh, let's make sure, let's look at that. I prime should be up here, I'm sorry. Let's go back to I prime just a second. Okay, this should have been a positive 1. Sorry, the original should have been negative 3, positive 1, which is going to change that to a positive. Okay, all right, so let's graph it now. 1, 2, 3, 4. I bet some of y'all caught that when I did that, and I didn't catch it. I wish I had. I'm sorry. I do apologize. All right, so 1, 2, 3, 4.5, up 1.5. There is I prime. Okay. All right. What about J? Okay. So left 1.5, up 1.5. Don't let these halves mess with you and fool you and make you upset, because we can have halves on the coordinate plane. Okay. All right. I'm going to do my best to connect this. So let's see what it looks like. I can already see, except for that one, I can already see that it is definitely getting bigger, which is what I wanted it to do, since my scale factor was bigger than 1. All right, that's a terrible one. Let's try to fix that. Okay, and if you'll look, I have now increased the size of that original star 1.5 times, which made it get bigger. Okay, so you see, all we're doing, guys, remember, as just as a recap, all you're doing is you're taking that pair. I can do it without a coordinate plane. Again, I can do this over here. What if I had a point, let's just say 2, 9, okay, and I wanted to find out what a prime is by using a scale factor of 3. Well, what I'm actually doing is these numbers right here are going to be 3 times bigger when I finish. But all I'm doing is taking the x coordinate multiplying it by 3. So 2 is going to become 6. And then taking the y coordinate, multiplying it by 3, which gives me 27. Okay? So they just getting bigger based off of that scale factor. Okay? And notice scale factor means to multiply. All right? Hopefully that helps. Go back and watch it again if you need to. And if you have any questions, let me know tomorrow. Okay? You guys have a great evening.